Okay, welcome back. We're doing chapter 2, section 8, solving absolute value equations and inequalities. Still on page 154. This time we're going to do problems 5 through 7, where we're going to solve equations that have absolute values. And remember, for this problem, what is inside the absolute value is going to equal 2, or it's going to equal negative 2. And one question people come up with in class is this a conjunction or a disjunction? The two answers that we have are going to be distinct from each other. You cannot have a value that's both two numbers at the same time. So you can't have a person who's both 14 years old and 17 years old at the same time. So this technically will be a disjunction, but don't concern yourself too much with that. We get into the use of the word and or a lot, and it's something like, I do try to teach, but I understand it's a little difficult when we have situations. So for these are all going to be disjunctions, but don't worry about that, right? So the first one, what I have here, the x plus 5, if I take the absolute value of that, that's going to equal 2. So one thing that could happen is I could say x plus 5 does equal positive 2, because these are equal to each other. So the absolute value of 2 is 2. There's a word or, the other thing is this could be negative 2. So x plus 5 could equal negative 2. I'm going to solve both of these by subtracting 5, and I get x equals negative 3. I'm going to do the same thing over here by subtracting 5, except in this case I get x equals negative 7. For problem number 6, I have to isolate the absolute value bars first, or the absolute value expression. I'm going to write that all out. Except I just abbreviated because I was running out of time. So this absolute value of 2x has to be all alone on its side of the equal sign. The minus 6 is in the wrong place. So I'm going to start by adding 6 to both sides, and I get the absolute value of 2x equals 10. Now, like in the previous problems, the absolute value is all by itself on the left side. Same thing that I've been able to do here. You have to do that first. So you're not going to write plus or minus 4. I get 2x equals 10, or 2x equals negative 10. Divide both sides by 2, I get x equals 5. Divide both sides by 2, I get x equals negative 5. Now this is one of the examples where as soon as you get one of the solutions, the other solution is its opposite. That's because you're multiplying. In this problem, I got x equals negative 3, but that is not positive 3. So you have to be very, very careful. Don't just assume it's always going to be one number and its opposite. We'll do one more in this section. Again, I have, I have to isolate the absolute value bars. So I'm going to subtract 4 from both sides, and I get the absolute value of the opposite of x equals 3. Now, let's go ahead and solve this the way we were talking about it, because I think that negative sign might be a little confusing, and then we'll go back and see, was there something that actually helped clear that up? So, I've got the opposite of x could equal positive 3. So what's under my thumb right here could equal positive 3. The absolute value of 3 does equal 3. So this could equal 3. Or the opposite of x could equal negative 3. So I get x equals negative 3 here, and over here I get x equals positive 3. Now, I want to go back to this and say, well, what if I had done the absolute value of negative x? Wouldn't that just be the absolute value of x? And I would still get 3 and negative 3. That's true in this case. And it's probably going to be true in a lot of other cases. But one of the things that I know from the experience of working through a lot of these problems is that we want to be mindful of the fact that if we follow the steps, we know that we're going to be doing it right, where instead possibly we might be doing something that could be a little bit confusing. Okay, so in this case it would have worked out if we'd done that. In another case maybe it wouldn't, so we'll have to see. All right, see you in the next video.